Welcome to Microsoft Virtual Academy. Today's course is Virtualizing Linux and FreeBSD workloads on Windows Server 2012 R2. If you take a look at our agenda, first of all we are going to talk about why should we consider running Linux and FreeBSD workloads on Windows Server 2012 R2. Then we will talk about Linux integration services and FreeBSD integration services. These integration services are the essential parts of virtualizing Linux and FreeBSD on Hyper-V. I will let you know why they are so important and why you should spend some time planning which versions, which distributions you should use on Linux and on Hyper-V for Linux and FreeBSD workloads. So let's start with Module 1. Why Windows Server 2012 R2 for virtualizing Linux and FreeBSD? Our goals are actually very simple. Our first goal is provide you simply the best experience for running Linux and FreeBSD on Hyper-V, and also on Microsoft's public cloud offering, Microsoft Azure. We also want you to have a great choice of availability in running Linux and FreeBSD workloads. So you will be able to run Windows failover clusters and put your Linux workloads in that failover clusters. So you will have high available Linux servers and FreeBSD servers. And lastly, we want you to easily manage and extend your Linux and FreeBSD workloads. That means by using Microsoft products, by using a single pane of glass, for example, Windows Server and System Center, we want to enable you to manage your both Windows and Linux and also FreeBSD workloads running in your environment. If you take a look at why we are going that way, so why are we embracing open source Linux and FreeBSD that much? We understand that, we realize that the world, the IT world, is an heterogeneous environment. So we want you to be able to deploy Linux and FreeBSD as a first-class citizen on Hyper-V. We have broad support. Most of the enterprise versions are available on Hyper-V. By enterprise, we mean we are not planning to support like distributions like hobbyist distributions, because we want our customers to be able to contact the Linux vendor and also Microsoft sometimes about getting support when they have a problem, when they have issues about running Linux on Hyper-V. We also enable you to run Linux and Windows virtual machines on the same Hyper-V server. So we are not asking you to, separate your Linux workloads, separate your Windows servers. We don't say that. We say that if you have invested in Hyper-V, that's fine. You can just start running Linux and FreeBSD workloads in your Hyper-V servers, provided they are running Windows Server 2012 R2. We have also invested in networking. So for Linux virtual machines, for example, I'm going to give a little bit more detail in Module 2. You can now use VRSS, Virtual Receive Site Scaling. Scalability. In the previous versions of Windows Server, scalability may be a problem for Linux workloads. But starting with Windows Server 2012 and even more enhanced in Windows Server 2012 R2, scalability is not a problem anymore. You are able to add 64 virtual CPUs to your Linux virtual machines, 1 terabyte of RAM to your virtual machines, and 64 terabytes of disk per disk to your Linux virtual machines. Also, storage is an area we have invested. You can, for example, provided you have a SCSI drive on your Linux virtual machine and it's a fixed size VHDX, you can increase the size, you can resize that disk without turning off the virtual machine. So it's a live online resize. In the past, in some cases, when you are taking backups of your Linux virtual machines running on top of your Hyper-V servers, the virtual machine was paused for a brief period to be able to take the backup of the virtual machine. In Windows Server 2012 R2, we now provide you live backup for Linux virtual machines. That means when you are taking a backup of that server in the virtual machine level, in your Hyper-V server, it will be live. The virtual machine will not be paused, will not be turned off. You can just continue using the virtual machine while the backup is in progress. So I talked about scalability. I want to elaborate a little bit more about this. With Windows Server 2012 R2, you are now able to add again 64 virtual CPUs per virtual machine, 1 terabyte of RAM per virtual machine. On the server side, you can have 4 terabytes of RAM. You can have 320 logical processors on the physical server. And if you are running a failover cluster in Windows Server 2012 R2, you can add 64 nodes to that cluster and run 8,000 machines in that cluster. So this is beyond the limits of many enterprises today. But what we think is, in the past, sometimes, even if you have the hardware capable of running very high-level workloads, the operating system, the virtualization stack, may be limiting you. So right now, what we are saying is, if you have the hardware resources, if your server is capable of doing this, Windows Server 2012 R2 will provide support for this. So if your server has 4 terabytes of RAM, you can utilize all 4 terabytes of that RAM. And by support, again, I want to mention that thing again. By support, Microsoft means we have tested this configuration, and these are the limits of our tests. So theoretically, you can go even beyond these limits. But the tested limits, the supported limits by Microsoft, are the limits you can see in the slides at the moment. When we take a look at the supported Linux distributions, you can see that all the enterprise distributions are available, like Red Hat, Oracle, Ubuntu, Debian, SUSE, OpenSUSE, and so on. And our Linux team is really working hard to give you support about the newest versions of the Linux virtual machines. For example, you can see that for CentOS 7, the support is there. Oracle Linux 7 support is there. So even if you're not seeing your version in the table, in the supported versions table, probably in very near future it will be added to Hyper-V's supported Linux distributions, and you can get support from Microsoft about that distribution. Once again, if you want to have more information about Windows Server 2012 R2, you can just go to TechNet Evaluation Center and download the evaluation version and use it for 180 days. It's 6 months. So just go ahead and download Windows Server 2012 R2 evaluation version. Just install it in a virtual machine, or if you have a physical server, it's even better, and start using it immediately. Another option of you is going to TechNet Virtual Labs. So you can just go to TechNet Virtual Labs, start an online environment that was prepared just for you. It has virtual machines and a step-by-step instruction document. So you can just follow these steps and complete the scenarios on your own anytime you like. In the next module, we will talk about Linux integration services. Welcome to Module 2 of the MVA course called Virtualizing Linux and FreeBSD Workloads on Windows Server 2012 R2. In that module, I'm going to talk about Linux Integration Services, or LIS. So before I start, let me give you a brief explanation how operating systems run on Hyper-V. The first thing that should be checked is that if the operating system runs on x86 or x64 architecture. If it's not, you will not be able to run this workload on Hyper-V. Some examples are AIX, HP UX, Solaris Spark, and Windows RT. If it is running on x86 or x64, then the next question is there any integration services running in the virtual machine? If you don't have any integration services installed and running in the virtual machine will be running, but you will have limited performance because you will be using what we call emulated devices. So you won't have any Hyper-V integration, you don't have any communication between the virtualization stack and the virtual machine. The manageability will be limited, and the disk performance and especially the network performance will be really low compared to a virtual machine running with integration services. Some examples are Linux or BSD, FreeBSD machines without any integration services. If there is integration services included in that virtual machine, Linux virtual machine, let's be more precise, you will be able to use synthetic devices. These devices are designed for Hyper-V, so you will have full Hyper-V integration. I'm going to talk about the features you will be getting with integration services in the later part of this module, but you will have full integration. You will have near physical server performance, near bare metal performance. So integration services is a very important and core part of running virtual machines on Hyper-V, not limited to Linux or FreeBSD, but also for Windows virtual machines, integration services is a critical component. What are these integration services? Basically, they are synthetic devices in the guest OS. You can think of them like device drivers. So, as you can see in the presentation, it doesn't matter if you're running Linux, FreeBSD, or Windows. These virtual machines have hardware. It may be virtual hardware, but at the end of the day, they have disks, network cards, CPUs, and so on. So when you are using Hyper-V, Hyper-V basically presents these synthetic devices to the guest operating system. And these devices, they need drivers just like any other server in the world. So let's say you have bought a new network card for your server. You need to download the driver and install the driver. It's the same for the virtual machines. And of course, since they are treated like usual common drivers, the rules are the same. They have daemons to interact with the users, and they must follow the device driver model for running virtual machines in Hyper-V. So they are device drivers. So how we are developing these device drivers? For Windows workloads, Microsoft is providing the full development phase. But for Linux integration services, we are doing this a little bit different than we are doing it with Windows. So Microsoft developers, in Windows world, Microsoft developers, they just develop these integration services and they put it inside Hyper-V, and you can just download these integration services, and then the customer, as a customer, you can go to Microsoft Download Center, download this package, and install it in your virtual machines. But the model we have changed is we are now developing Linux integration services and open sourcing them. So we put it in, actually we are upstreaming it. We put it for community review. Then the community reviews the code. And after that, it is part of the Linux kernel. So the integration services comes built in with the Linux distributions. You can see we are working very closely with the vendors listed here like Ubuntu, Red Hat, CentOS, SUSE Linux. And if you are using a rather new version of these Linux distributions, the integration services are built in. You do not need to go to a download center, download the package, install the package, and start running that integration services. They come within the kernel. So let's take a look at the feature descriptions. So we are using integration services. What do they provide us? The first one is integrated shutdown. Very basic but very useful ability. So when you are in Hyper-V Manager, when you right click on a virtual machine, you can just click on shutdown and your Linux virtual machine will shut down gracefully. Of course, you can do this programmatically like using the API or using PowerShell. But main idea is you are able to shut down the virtual machine remotely without logging to the virtual machine. And if you go inside and want to check which driver, which part of the driver, which daemon is providing us this, it's HV utils under Linux integration services. Next one is time synchronization. So this feature enables you to set your virtual machine to get its time from the physical host. So if you want your virtual machine to use as time synchronization between the Hyper-V host and the virtual machine, the Linux integration services makes this possible. And again, this is part of HV utils driver. Multiprocessing support. In the beginning of the course, I mentioned that you can now add up to 64 virtual CPUs to a virtual machine. Because of these Linux integration services, we are able to provide you 64 virtual CPUs per virtual machine. Next one is called Heartbeat. It's a basic monitoring service. It's just monitoring the virtual machines running on top of this Hyper-V server and reports back. This is again a part of HV utils driver package. Integrated mouse support. Again, a very basic feature, but if you don't have this, it's really annoying. Let's say you are installing an old version of a Linux distribution. Even while you are installing the virtual machine, you are not able to use your mouse. Installation finished, Linux virtual machine started working, the mouse, it doesn't work again. So when you have the integrated mouse support by installing Linux integration services, even when you are installing the virtual machine, you can use your mouse. And also we had some reports back from our customers that they see two mouse pointers when they are using a Linux virtual machine on Hyper-V. The new integrated mouse support also fixes this. The next one is Hyper-V storage and network devices. One of the most important improvements, because this is directly affecting the performance you are getting from your virtual machine. So if you have the integration services installed, you will have synthetic devices. So what means they are not going to consume the CPU of your server to run these virtual devices. They will just run as just like they are a hardware in the server. Jumbo frames. So jumbo frames means you being able to use an MTU size of more than 1500. If you have Linux integration services installed and updated for Linux virtual machines, you can use jumbo frames. VLAN tagging and trunking. It's one of the most common way of design, network design nowadays. So if you are using VLANs and if you are doing trunking in your switches, by using the updated version of integration services, you are able to use VLANs and trunking. Live migration. Another crucial part of our nowadays infrastructure. It is the ability to migrate a virtual machine from one physical host to another physical host without any downtime. So you just basically migrate the virtual machine from host A to host B, but the virtual machine keeps running when it's being migrated. This is again one of the goodies coming with Linux integration services for Linux workloads. Static IP injection. Windows Server 2012 and Windows Server 2012 R2 has a great feature called Hyper-V Replica. It's a feature that enables you to build a disaster recovery environment for your servers. So basically, it makes a copy of your source virtual machine and puts it in a target Hyper-V server. One problem in disaster recovery would be your virtual machine is running in the current host at the moment, and in the current network infrastructure, it may be using an IP from 192.168.10 dot something. But in the disaster site, maybe the IP block is different. So static IP injection enables you to enter a secondary IP to this virtual machine, a failover IP. So basically, you say Hyper-V, okay, Hyper-V, if there's a failure and I fail over this virtual machine to the failover site, when you are starting to run that virtual machine, make sure that you inject that IP address I have specified in the settings. So even if you are using a different IP block in the source host, the virtual machine will be able to start running with a different IP. And of course, different subnet, different gateway and DNS. Virtual RSS, virtual receive site scaling. Let me go a little bit deep on that. So without RSS, you are able to use only a single physical core in your physical server. In the beginning, this RSS feature was also available in physical servers. So if you don't have RSS support in your network card, the incoming packets, the network traffic, was using only one physical server, physical CPU, physical core in the physical server CPU. But if you have RSS, now the network traffic can be managed by using more than one physical core in your physical server. Virtual receive site scaling is doing the same thing in the virtual machine level. So it's again RSS, receive site scaling, but now your virtual machines are able to use more than one virtual CPU to manage network traffic. So of course, it gives you the ability to reach much higher speeds than normal. You may be using a 4 gig network card, you may be using 10 gig network cards. If you are not using virtual RSS, VRSS, you will be limited around 4 gigs of network bandwidth, because the virtual machine will be using only one single virtual CPU in that virtual machine. But if you are using RSS, it now utilizes all of the virtual processors, and it can spread the traffic using these virtual processors. VHDX resize. One of the requests coming especially from our service providers, you are now able to resize a fixed size VHDX while the virtual machine is running. So let's say you have a Linux virtual machine, you have added a 5 gigabyte VHDX to that virtual machine as a secondary disk using a SCSI adapter. That part is really important. And you need to resize it. You need to make it 50 gig. So you can just go to Hyper-V and resize this VHDX while Linux is running. Linux is really capable of understanding that the disk size is increased in the host level, in the physical level, and it just adopts accordingly. So you don't even have to go ask Linux anything about to do it. Most of the time, Linux just understands that there's a change in hardware and start using it. You can see that this is possible by using SCSI disks. One other important point is, if you are doing this for Linux workloads, the VHDX should be a fixed size VHDX. Virtual fiber channel. So now you can provide access to your Linux virtual machine directly to your fiber devices. So the configuration is more or less the same you are using with physical hardware. You do the same masking and zoning thing, and you set the worldwide name, but this time you are doing this on the virtual machine level. So you can see that we are setting 2 worldwide names per virtual machine. This is the reason we are doing this like this is to provide live migration support for virtual machines. So the second set will be copied to all other servers in the cluster, and even if you live migrate this virtual machine to another node in the physical cluster, it just starts using the other worldwide name, and the virtual machine won't have any downtime. Live virtual machine backup. As I mentioned again in the first module, in the past you are not able to take a backup of your Linux virtual machines without pausing them or without shutting them down. Right now you don't need to worry about this, because you can now take live backups of your Linux virtual machines running on top of Hyper-V. There are some tips and tricks about this. You can find detailed information in TechNet documentation, like you can see in the slide one of them. But if you fulfill these requirements, it just works. Trim support. So trim support is basically you are using, let's say, 10 gigabytes of storage space on your virtual machine. Then you have deleted some of the files and it shrinks back to 6 gigabytes. If you have a trim support in your hypervisor level, it just understands that this space is now deleted and not being used, and it just does the math and purges the space automatically. You are now able to configure MMIO gap. Linux-based appliance manufacturers use the MMIO gap to divide available physical memory between the just enough operating system that boots up the appliance and the actual software infrastructure that powers the appliance. So before Windows Server 2012 R2, you weren't able to configure an MMIO gap, but now if you are an appliance producer, you can just use and set the MMIO gap in Windows Server 2012 R2 for your Linux-based appliances. Dynamic memory. So hopefully everybody is using this. It gives you the ability to dynamically increase and decrease the amount of the memory provided to the virtual machine automatically by the Hyper-V level. So you can both do hot add memory or you can do ballooning in Hyper-V. And let's see how it works. We have settings like minimum and startup memory. That means startup memory means servers need the majority of the memory when they are starting up. So you can just set a different startup memory setting for a virtual machine, telling Hyper-V, okay, when this Linux VM 01 is starting, give that virtual machine 2 gigabytes of RAM. But when the start phase is over, and if the virtual machine is not needing 2 gigabytes of RAM, just decrease the amount of memory that the virtual machine is consuming, and do this automatically. You can also set a minimum and maximum amount of RAM, and these minimum and maximum amounts, the rules you have set, will be used by Hyper-V as guidelines. So if the virtual machine is not consuming memory, Hyper-V will try to go down to minimum memory size. And if the virtual machine is requesting to use more memory than it's actually using, Hyper-V will just add more RAM to the virtual machine until, of course, up until to the maximum limit you have set. You can see in the presentation that it works automatically, and it just works. The second feature coming with Windows Server 2012 is called Smart Paging. So Smart Paging is when you are restarting the virtual machines, let's say your physical server, it doesn't have any memory left to provide to the virtual machines. In that case, in the no physical memory is available on the physical server case, Hyper-V can just use the disk drives to be used as a memory and present this disk as memory to the virtual machines. Of course, it will be slower than using the actual physical memory, but the main idea behind Smart Paging is you will be able to start your virtual machines. This is, of course, I think giving us an idea that we need to focus on planning a lot. So if your physical server has 32 gigabytes of RAM and you have 20 virtual machines with their startup RAM set to 2 gigabytes per virtual machines, you may have a problem like this. But if Smart Paging was not as a feature in Hyper-V, your virtual machines would not be able to even start. But with Smart Paging, even working a little bit slower than expected, they will start, and after the startup period is over, when they are not needing too much memory, the memory levels will be decreased by Hyper-V and all of your virtual machines will start running normally as expected. You can, of course, configure which disk to be used as the Smart Paging disk. So you can use a SSD disk, for example, and performance will be better compared to a normal SAS or SATA disk. You now have video support. So we have, we can say that we have redeployed the Linux video driver in integration services. So right now the performance is much higher compared to the previous versions of Hyper-V, and you can have full HD resolution in your Linux virtual machines. Key value pair exchange. This service provides an exchange between the virtual machine and the Hyper-V host. Most of the software is using this. The problem about using this is this needs to be secure, so the host and the virtual machine should be communicating in a secure manner. So by using integration services, you are making sure that everything is secure and the performance is good as expected. And this is part of the HV utils and HV KVP daemon. So if you want to use this service in your Linux virtual machines, make sure these are installed and the daemon is up and running. Non-maskable interrupt. So by using this, you can just panic the system in your Linux virtual machine. So it's really simple to use. You can see an example here. There are no NMIs, non-maskable interrupts in the Linux server. Just a one-liner in PowerShell. You basically force the virtual machine to do a non-maskable interrupt, and you can check that there is one NMI in proc interrupts. So if you have a problem in your virtual machine, it's somehow you cannot access it, something is happening inside, you need to panic the system, you can just do this in the physical hosts. You don't need to log in to the virtual machine itself. You can now use Linux versions with PAE support. So this gives you the ability to use a 32-bit kernel and address memory spaces that are more than 4 gigabytes. File copy from host to guest. Again, very basic but very useful and neat feature. Right now you can just copy a file from your physical Hyper-V server to the Linux virtual machine, and you can just do this using a PowerShell commandlet, copy file commandlet, and this is also a part of the Hyper-V utils and fcopy daemon services. So if you want to use this, make sure the daemon Hyper-V fcopy is up and running inside your Linux virtual machine. Okay, we have talked about the features available coming with these Linux integration services. Let's take a look at what are the best practices for running Linux on Hyper-V. It's not a long list, but make sure you are applying these best practices in your Linux environments if you are running them on Hyper-V. The first one is, if you are using failover clustering, if you have a Windows failover cluster in your environment, make sure the Linux virtual machines running in that cluster has a static MAC address. So you can just go to Hyper-V settings of the virtual machine and set the static MAC address. Let me show you how we can do this. So here I am on my Hyper-V server. I am just entering the settings of one of my Ubuntu virtual machines. And you can see I have a network adapter here. And under advanced features, you can see that you have options dynamic and static. Of course, since that virtual machine is running at the moment, you cannot change the MAC address setting, but if you shut down the virtual machine and set a static setting for that virtual machine, you won't have any problems while you are running this virtual machine in a Hyper-V cluster. Going back to my slides. So please use the synthetic network adapter. Don't use the legacy network adapter. When you are adding a new network card, network adapter to your virtual machine, make sure it's a synthetic Hyper-V network adapter, because the performance is really low of these legacy network adapters compared to the synthetic ones. And the I/O scheduler setting should be no op, no operation. So you can just go to your etc grep conf file and you can set your operation level scheduler to no op. This will make sure that Hyper-V is running in the best performance level in terms of scheduling. If you have a virtual machine that has more than 7 virtual processors and 30 gigabytes of RAM, make sure you again go to your etc grep.conf file and add the setting NUMA off. NUMA is non-uniform memory access, and it's basically the way Hyper-V and of course the physical servers handle how virtual machines are accessing the physical memory on the physical servers. So in order to provide better support for your Linux virtual machine, if you have more than 7 virtual CPUs or more than 30 gigs of RAM on that Linux virtual machine, go to your bootloader and set NUMA off. And if you need to run a kdump or kexec, make sure you increase the value of crash kernel. Again, you can just go to your bootloader file and add the setting like 368 megabytes and 256 megabytes in that file. So that wraps up all the features coming with Linux integration services. If you are running at the moment, or if you are planning to run Linux virtual machines in the future on Hyper-V, make sure the integration services inside your virtual machines are updated, and make sure you are following the best practices I have mentioned here. The documentation in TechNet is evolving, so please make sure you are checking the documentation, and see you in the next module. In the next module, I'm going to talk about FreeBSD integration services. Welcome to Module 3 of the MBA course, Virtualizing Linux and FreeBSD Workloads on Windows Server 2012 R2. In that module, I'm going to talk about FreeBSD integration services. So again, why FreeBSD is important? Just like Linux, we understand that FreeBSD is a core part of some of our customers. And the main idea behind our FreeBSD efforts is that most of the virtual appliance vendors are providing their products in FreeBSD platforms. Another thing that we consider is that if the customer is running FreeBSD, they are running a single hypervisor for running their FreeBSD workloads. And finally, we understand that we are in the process of providing virtual appliance offerings in Azure. So in order to provide more support about this possible virtual appliances that are running on Microsoft Azure, we are working very hard to make sure the FreeBSD integration services are giving you the best support and performance for your FreeBSD virtual machines. So let's take a look at how we are doing this FreeBSD integration services about development, distribution, and support. So you can see that the main thing you need to consider is getting support. If you have questions about a vanilla FreeBSD virtual machine, you can contact FreeBSD directly. If you are having issues running FreeBSD on your Hyper-V platform, you can either contact Microsoft or FreeBSD. But if you are having issues running a virtual appliance on Hyper-V, you need to contact the virtual appliance vendor directly. So for issues running FreeBSD workloads on Hyper-V, you can either go to FreeBSD or Microsoft. Let's take a look at what we are offering today, what's available today. Integration services version 1 is built into FreeBSD 10 today. It's a little bit lacking core support about performance, and it is supported on a best effort basis by Microsoft. So if you call Microsoft for support, what we are trying to achieve will be under the best effort umbrella. Integration services version 2 is available on FreeBSD 10 and later today. So it includes much more investments, especially in core areas, to enable you as customers to run this FreeBSD in production environments. We have signal optimization. We now have the key value pair exchange driver and daemon. And we scheduled to upstream this to version 10.2, but we will also port it to 10.1. And this new integration services, version 2.0, will be supported by Microsoft Customer Support. Let's take a look at the feature availability. I have covered what these features provide us in the previous module, so you can just check the previous module to get more information about the descriptions of these features. But you can see that depending on the Hyper-V version, depending on what version of Windows Server you are using, and of course depending on the FreeBSD version, the features, the available features are changing. But again, we are working very hard to add more and more features available to FreeBSD. So you can just check this availability table on TechNet documentation if you are planning to run FreeBSD workloads. And how about FreeBSD in Microsoft Azure? So we are talking about running FreeBSD workloads in Hyper-V in our on-premises environments, but you are also able to run FreeBSD virtual machines in Microsoft Azure. You can just go to VM depot and start deploying FreeBSD virtual machines. And the virtual machines in our VM depot are both provided by the contributors. It may be an individual, but also FreeBSD is publishing images to Microsoft Azure VM depot. Or you can just bring your own FreeBSD virtual machine running in your on-premises environment, and provided that you have installed the integration services and the Microsoft Azure agent, Linux agent, you can move that on-premises virtual machine to Microsoft's public cloud, Microsoft Azure. So, to sum up, we are working hard to provide the best experience to our customers if they want to run Linux or FreeBSD virtual machines on top of Hyper-V or, of course, Microsoft Azure. We are also working hard to give our customers choices. So because it's all about choices, we are not trying to force you to do something, but what we are trying to do is we are trying to give you options. So if you want to run Linux on premises, on Hyper-V, you can run. If you need to run FreeBSD virtual machines on premises, you can do that. If you'd like to run these workloads in our public cloud in Microsoft Azure, it is also possible. So it's all about choices. And finally, we are working hard to enable you to manage and extend your infrastructure, meaning you can just use System Center and Windows Server to run and manage all of these workloads I have mentioned. Whether it's Windows Server, Linux or FreeBSD, you will just use a single pane of glass. And in case you want to extend your infrastructure to Microsoft Azure, you will be able to use Microsoft Azure as an extension to your on-premises environment. So all of these choices are available today with Windows Server 2012 R2, and with the next versions of Windows Server and System Center, the support, the available features and the performance will be even better because, as I said, the Linux team, the open source team in Microsoft is working really hard and working really closely with the vendors. So we provide you the best option to run open source products, especially Linux and FreeBSD on Hyper-V or Microsoft Azure. So thank you very much for joining the course. Hopefully it was beneficial. If you have questions about how to run Linux on Hyper-V or how to run FreeBSD on Hyper-V, please make sure you check TechNet documentation. We have great documentation there. You can learn about the features, you can learn about best practices, you can learn about tips and tricks. And again, please go ahead and download the evaluation versions. You can download the eval of Windows Server 2012 R2 and use it for testing for 6 months. So it's the best way to learn how the product works in action. And another option is, again, TechNet Virtual Labs. You can just Bing for TechNet Virtual Labs and choose the lab you like. You can just start doing step-by-step using step-by-step instructions. You can complete scenarios and learn how our products are making your daily IT life easier. Thank you and hope to meet you soon.